When a wire is stretched by a force, the strain produced in the wire is 2 into 10 raised to minus 4. If the energy stored per unit volume of the wire is 4 into 10 raised to 4 joules per meter cube, then the Young's modulus of the material of the wire will be, there are the options. Now the energy per unit volume is given by half into y into the strain square. Now we need to find the value of the Young's modulus. Therefore, energy per unit volume is given as 4 into 10 raised to 4 half into y, and strain is given as 2 into 10 raised to minus 4 the whole square. Therefore, y is equal to 2 into 10 raised to 12 Newton per meter square. Therefore, here the correct answer will be option C. Wire of length L and area of cross section A is made of a material of Young's modulus Y. If A is stretched by an amount X, the work done is given by, here are the many options. Now the Young's modulus Y is equal to F into L upon A into X. Therefore F is equal to Y into A into X upon L. Now the work done will be equal to the force into the average extension. Therefore, the work done will be F into X upon 2, which is equal to Y A X square upon 2L. Substitute the value of F from this equation. Therefore, here the correct answer will be option C. Wire suspended vertically from one of its ends is stretched by attaching a weight of 200 newtons to the lower end. The weight stretches the wire by 2 millimeters. The elastic energy stored in the wire is, here are the options. Now the elastic energy E is given by the formula half into the load into the extension. Here the load is given by 200 newtons and the extension produced is 2 millimeters, which on converting to meters is 2 into 10 raised to minus 3. Therefore, on calculating all this, we get 200 into 10 raised to minus 3 joules, which is 0.2 joules. Therefore, the correct answer here is option B. Two springs of force constant K and 2K are stretched by the same force. If E1 and E2 are the potential energy stored in them respectively, then these are the relationships of E2. Which one should be the correct answer? Now, if X is the extension for the force constant K, then for the spring constant 2K, the extension will be X by 2. Therefore, the potential energy E1 will be half into K into X square, and E2 will be half into K into X by 2 the whole square, which is 1 upon 4 Kx square. This will be 2K, so 2 will get cancelled, and 2 square, which is 1 by 4 Kx square. Therefore, E1 will be equal to 2 E2. Therefore, here the correct relation will be option B. Young's moduli of brass and steel are in the ratio of 1:2. A brass wire and a steel wire of the same length are extended by the same amount under the same deforming force. If RB and RS are the radii of brass and steel wires respectively, then here are the options. Here are the relationship between the radii of the two, brass and steel. Which one of them is the correct one? Now, YB, Young's modulus of brass, upon Young's modulus of steel is given in the ratio as 1 upon 2. We also know that YB upon YS is equal to radii of the steel square upon radii of the brass square. Therefore, from 1 and 2, we get RS square upon RB square is equal to 1 by 2. Therefore, RS square will be 2 RB square. On taking square root on both sides, we get RS is equal to root 2 RB. Therefore, the correct answer here is option C. Extension in wire obeying Hooke's law is X. The speed of sound in the stretched wire is V. If the extension in the wire is increased to 4x, then the speed of sound will be, here are the options. Now, speed of sound V is given by the formula root of T by M. But by Hooke's law, T is directly proportional to X. Therefore, V is directly proportional to root x. Substituting the values x in place of t. Therefore, V2 upon V1 will be equal to root of x2 upon x1, which is equal to 2 volts. Therefore, here the correct answer will be B. Accessibility of water is 4 into 10 raised to minus 5 per unit atmospheric pressure. 100 cc of water is subjected to a change of pressure of 100 atmosphere. What is the change in the volume of water? Here are the options. Now, the compressibility is given by 1 upon the bulk modulus. Therefore, the bulk modulus B is given by the formula V dP upon dV. Therefore, dV, which we have to calculate the change in the volume, dV equal to V dP into 1 upon B. Now 1 upon B is the compressibility, which is given as 4 into 10 raised to minus 5. Therefore, substituting the values of all the equations, we get the answer as 0.4 cc, which is the change in the volume. Therefore, the correct answer will be option D. Wire of length L and radius R is loaded with a weight of mg. If Y and rho denote the Young's modulus and the Poisson's ratio of the material of the wire respectively, then the decrease in the radius of the wire is given by, here are the options. So we need to find delta R. Now, the Young's modulus or the Poisson's ratio is given by delta R upon R is equal to Poisson's ratio delta L upon L. Now, the Young's modulus is given by Y is equal to mgl upon pi r square delta L. Therefore, we need to substitute delta L upon L here. Therefore, taking delta L upon L on the left hand side, we get mg upon pi r square Y. Therefore, substituting the value of delta L upon L in the first equation, we get delta R upon R is equal to rho into mg upon pi r square into Y. Now R and R will get cancelled. Therefore, the change in the radius of the wire will be given by rho into mg upon pi r Y, which is option C. Of length 3 meter and diameter 1 millimeter is stretched to increase its length by 0.3 meters. What is the lateral contraction if the Poisson's ratio for copper is 0.25? Now, Poisson's ratio is given by the formula rho is equal to delta L delta D upon delta L upon L. Therefore, delta D upon D will be equal to rho into delta L upon L. Here we need to find the value of delta D. Therefore, delta D will be equal to 0.25 into 0.3 into 10 raised to minus 2 upon 3, which is 0.25 into 10 raised to minus 3. Therefore, delta D is equal to 25 into 10 raised to minus 5 into 1 into 10 raised to minus 3, which is equal to 2.5 into 10 raised to minus 7 meters. Therefore, here the correct answer will be option C. No change in the volume of a wire due to the change in its length on stretching. The Poisson's ratio of the material of the wire is, here are the options. Now, let D be the diameter and V be the volume of the wire. Therefore, V will be equal to pi d square L upon 4. Therefore, dV will be equal to 2D into delta D into L plus pi d square into delta L, which is equal to 0. Therefore, 2 delta D L will be equal to minus D delta L. Therefore, delta D upon D will be equal to minus half into delta L upon L. Therefore, Poisson's ratio is delta D upon D slash delta L upon L, which is minus half. Now, this is the theoretical value, but Poisson's ratio cannot be negative because when L increases, D decreases. Therefore, the answer is Poisson's ratio is 0.5. Therefore, the correct answer here is option A. When a load of 5 kg weight is applied to a wire of length 200 centimeter, its length increases by 2 centimeter. Then A. Its volume strain is 0.01. B. Shearing strain is 0.01. C. Longitudinal strain is 0.01. D. Its Poisson's ratio is 0.5. Now we all know that longitudinal strain is equal to elongation upon L. So we know the elongation, which is 2 centimeter, and the L as 200 upon 200, which will be 1 upon 100, which is 0.01. Therefore here the longitudinal strain is 0.01, which is option C. Force of 500 kg weight can break a wire. What is the force necessary to break another wire of the same material and same length but of half the cross sectional area? Here are the options. Now we know that the force and the area are related by this equation. F1, if there are two forces and two areas, they are related by F1 upon A1 is equal to F2 upon A2. But we know that one of the area is half another area. So let's A2 is equal to A1 upon 2. Therefore, F1 upon A1 will be equal to 2F2 upon A1. Therefore, F2 will be equal to F1 upon 2, which is equal to 250 kg weight. Therefore, here the correct answer is option B. B are two wires. The radius of A is twice that of B. If they are stretched by the same load, then the stress on B is A equal to that of A, 2 times that of A, 4 times that of A, half that of A. Now stress is equal to F upon A. Let R be the radius of B. Therefore, for A, F upon pi 2R square is equal to F upon pi 4R square. Therefore, this is for A. And for B, stress is equal to F upon pi R square. Therefore, F upon pi R square is equal to 4 into F upon pi R square. Therefore, stress of B is equal to 4 times stress of A. Therefore, here the correct answer is option C. External force of 20 newtons acts normally on a rectangular plate of length 20 centimeter and breadth 10 centimeters. What is the maximum stress produced in the plate? A. 100 Newton per meter square. B. 500 Newton per meter square. C. 1000 Newton per meter square. And D. 2000 Newton per meter square. Now, the stress is given by the formula force upon area. Now here the force acting is 20 newtons. However, no area is given, but the length and breadth are given. The area is length into breadth, which is 20 into 10 raised to minus 4 meter square, which is equal to 1000 Newton per meter square. Therefore, here the correct answer is option C. External force of 20 Newton acts at an angle of 60 degrees with the normal to the surface of a square plate having each side of length 20 centimeter. What is the stress produced in the plate? A. 100 Newton per meter square, 150 Newton per meter square, 200 Newton per meter square, and 250 Newton per meter square. Now here we know the angle at which the force acts. Therefore, the normal component of force is equal to F cos 60 degrees, which is equal to 10. Therefore, this will be the actually force applied, not 20. Therefore, the stress produced will be equal to force upon area, which is 10 newtons upon the area, which is side square. Therefore, 20 into 10 raised to minus 4. On calculating, we'll get the answer as 250 Newton per meter square. Therefore, the correct answer is option D. 150 centimeter long is stretched by applying a force. If the strain produced in the wire is 0.01, the increase in the length of the wire is 1 centimeter, 1.5 centimeter, 2 centimeter, and 0.5 centimeter. Now the strain produced is given by the formula strain is equal to the change in the length upon the original length. Therefore, the increase or the change in the length, we have to find the delta L. Therefore, delta L is equal to strain into L. Now the given strain is 0.01 and the wire is 150 centimeters, which is this. On calculating, we'll get the answer as 1.5 centimeters. Therefore, the correct answer is option B. A certain pressure is applied to a liquid of volume 5000 cc. Its volume decreases by 50 cc. In this case, the volume strain is A 0.1, B 0.5, C 0.01, and D 5. Now, since both the values are in cc, we won't convert it into liters. Therefore, the volume strain is given by dV upon V. Now the change in the volume or the volume decrease by 50, therefore 50 upon the volume, which is 5000, which gives the answer as 0.01. Therefore here the correct answer is option C. Would be the greatest length of a steel wire, which when fixed at one end can change freely without breaking. Here the density of the steel is 7800 kg per meter cube. Breaking stress for steel is 7.8 into 10 is to 8 Newton per meter square, and G is 10 meter per second square. Here are the options. Now the breaking stress is given by the formula mg upon A. We can put the value of m as A into L into D upon G upon A. A will get cancelled and we'll get that length into D to G. Here we need to find the value of L. Therefore, L will be equal to breaking stress upon D into G, which is 7.8 into 10 raised to 8 upon 7.8 into 10 raised to 3 into 10, which will be given as 10 raised to 4 meters, which is 10 kilometers. Therefore, the correct answer here is L is equal to 10 kilometers. Modulus of water is 2 into 10 raised to 9 Newton per meter square. The pressure required to reduce the given volume of water by 1% is given by A, B, C, or D. Now, the formula for bulk modulus is K, which is the bulk modulus, is equal to the volume into the change in the pressure upon the change in the volume. Therefore, we need to find the change in the pressure. Therefore, dP is equal to K into dV upon V. We know the value of K as 2 into 10 raised to 9, and the volume is then the required to reduce the given volume by 1%. Therefore, 1% is the reduced in change in the volume, which is 1 upon 100. Which on calculating we'll get 2 into 10 raised to 7 Newton per meter square. Therefore, here the correct answer is option A. Two wires have the diameters in the ratio 1:2, lengths in the ratio of 3:4, and Young's moduli in the ratio 2:3. If they are subjected to the same stretching force, then the ratio of the elongations produced in the wires is, here are the options. Now the Young's modulus is given by y is equal to F into L upon pi r square into the elongation. Therefore, the elongation will be equal to F into L upon pi r square into y. But F1 will be equal to F2 since both the force applied are the same. Therefore, the elongation E1 upon E2 will be equal to L1 upon L2 into R2 upon R1 the whole square into Y2 upon Y1. Therefore, we know the value of L1 upon L2, R2 upon R1, and Y2 upon Y1, which will be as 3 upon 4 into 2 upon 1 the whole square into 3 by 2. Therefore, we'll get the answer as 9 by 2, which is 4.5. Therefore, here the correct answer will be option C. Density of a uniform steel wire of mass 1.6 into 10 raised to minus 2 kg and length 2.5 meter is 8 into 10 raised to 3 kg per meter cube. When it is loaded by 8 kg, it elongates by 1.25 millimeters. If G is equal to 10 in 10 meter per second square, then the Young's modulus of the material of the wire is, here are the options. Now density is given by mass upon volume, which is equal to mass upon A into L. Therefore, to find the area of cross section, A will be equal to mass upon density into length. On substituting the values of m, d and L, we get the answer as 8 into 10 raised to minus 7 meters square. Therefore, to find the Young's modulus, the formula is y is equal to F into L upon A into E. We know the value of F, L, A from here and E, which is 8 into 10 into 2.5 upon 8 into 10 raised to minus 7 into 1.25 into 10 raised to minus 3. which will give the answer as 2 into 10 raised to 11 Newton per meter square. Therefore, here the correct answer will be option B. Two wires made from the same material have their lengths L and 2L and the radii 2R and R respectively. If they are stretched by the same force, their extensions are E1 and E2. The ratio E1 upon E2 is 1 is to 8, 8 is to 1, 1 is to 4 and 2 is to 1. Now, we know that an elongation is directly proportional to the length and elongation is inversely proportional to the r square or the radius square. Therefore, E1 upon E2 will be equal to L1 upon L2 into r square upon 4r square, which will be equal to half into 1 upon 4, which is 1 upon 8, which is equal to 1 is to 8. Therefore, here the correct answer will be option A. Plate has the dimension 10 centimeter into 10 centimeter into 1 millimeter. One of its faces having larger area is fixed and a tangential force is applied to the opposite larger face. If the lateral displacement between the two surfaces is 1.2 into 10 raised to minus 3 millimeter and the modulus of rigidity of the metal is 5 into 10 raised to 10 Newton per meter square, then the tangential force is, here are the options. Now we know that the theta is given by the displacement upon the length, which is 1.2 into 10 raised to minus 6 upon 10 raised to minus 3, which is equal to 1.2 into 10 raised to minus 3. And the modulus of rigidity is given by the formula eta is equal to F upon A into theta. Now, we have to find the tangential force F. Therefore, F will be equal to eta into A into theta, which is equal to 5 into 10 raised to 10 into 10 raised to 2 into 10 raised to minus 4 into 1.2 into 10 raised to minus 3. On calculating all this, we get the answer as 6 into 10 raised to 5 newtons. Therefore, here the correct answer is option C. The modulus of a liquid is 2 into 10 raised to 10 Newton per meter square. What is the percentage decrease in the volume of the liquid when the pressure is increased by 20 atmosphere? Where 1 atmosphere is equal to 10 raised to 5 Newton per meter square. Here are the options. Now the bulk modulus is given by the formula K is equal to V dP upon dV. Therefore, K dV is equal to K dV dP. Now, therefore, dV upon V is equal to dP upon K. Here, we know the bulk modulus is given as K and the pressure is increased by 20 atmosphere. Therefore, 20 into 10 raised to 5 upon 2 into 10 raised to 10, which is 10 raised to minus 4. Therefore, the percentage decrease is given by dV upon V into 100, which is 10 raised to minus 2, which is 0.01%. Therefore, here the correct answer will be option A. A steel wire of length 1 meter and radius 0.1 millimeter is elongated by 1 millimeter due to weight of 3.14 kg. If G is equal to 10 meter per second square, the Young's modulus of the steel wire will be, here are the options. Now the Young's modulus given by Y is equal to mgl upon pi r square into E. Here m is 3.14 kg, G is 10 and L is 1 meters. Pi is 3.14 into 10 raised to minus 4 the whole square, since radius is given as 0.1 millimeters and converted to meters, we'll get 10 raised to minus 4 the whole square into 10 raised to minus 3. This in calculation all this we'll get the answer as 10 raised to 12 Newton per meter square. Therefore, here the correct answer will be option B. A tensile force of 3.2 into 10 raised to 7 newtons doubles the length of a wire of cross section 3.2 into 10 raised to minus 4 meters square. The Young's modulus of the material of the wire is, here are the options. Now, Young's modulus Y is given by the stress required to double the length of the wire, which is equal to F upon pi r square, which is equal to 3.2 into 10 raised to 7 upon 3.2 into 10 raised to minus 4, which will be equal to 10 raised to 11 Newton per meter square. Therefore, the correct answer here is option B. I'm sorry, here the correct answer is option C. Is the force constant of a spring. The work done in increasing its extension from L1 to L2 will be, here are the options. Now, at extension L1, the stored energy will be half K L1 square. Now, at extension L2, the stored energy will be half K L2 the whole square. Therefore, work done in increasing the extension from L1 to L2 will be half K L2 square minus L1 square. Therefore, here the correct answer will be option D. Given material, the Young's modulus is 2.4 times that of the rigidity modulus. Its Poisson's ratio is 2.4, 1.2, 0.4, or 0.2. Now, the Young's modulus and the Poisson's ratio is related by the function relation y is equal to 2 into eta into 1 plus the Poisson's ratio. Therefore, 2.4 Poisson's y is given as 2.4 in times the rigidity modulus, which is eta. Therefore, 2.4 eta is equal to 2 eta 1 plus rho. Therefore, on calculating, we get as 1.2 is equal to 1 plus rho. Therefore, rho is equal to 1.2 minus 1, which is 0.2. Therefore, the correct answer here is option D. Coefficient of linear expansion of brass and steel are alpha 1 and alpha 2. If we take a brass rod of length small l1 and steel rod of length small l2 at 0 degrees Celsius, their difference in lengths l2 minus l1 will remain the same at a temperature if, here are the relations. Now, we know that the capital L2 is given by the formula small l2 into 1 plus alpha into delta, alpha 2 into delta into theta, and capital L1 is given by the formula L1 1 plus alpha 1 delta into theta. Therefore, the difference will be L2 minus L1, which is equal to small l2 minus small l1 plus delta theta, which will remain common, into L2 alpha 2 minus L1 alpha 1. So now we need to find the value of L2 minus L1. Therefore, L2 minus L1 is equal to L2 minus L1. So L2 alpha 2 minus L1 alpha 1 will be equal to 0. This is the correct relation. Therefore, L1 alpha 1 will be equal to L2 alpha 2, which is the correct answer, which is option D. Wire of length 20 centimeter and uniform cross-sectional area of 1 millimeter square is tied rigidly at both the ends at 45 degrees Celsius. If the temperature of the wire is decreased to 20 degrees Celsius, then the change in the tension of the wire will be, here are the options. Now, Young's modulus is given as well as the coefficient for linear expansion is also given. Now we know that alpha, which is the coefficient of linear expansion, is given by the change in the length upon the original length into the change in the temperature. Therefore, the change in the length upon L will be equal to alpha into the change in the temperature. Therefore, Young's modulus is given by the formula F upon A into the change in the length upon the original length. From equation 1, substitute the value. Here we get F upon A into alpha into delta theta. So now we know the value of, now we need to find the value of the force. Therefore, F will be equal to 2 into 10 raised to 11 into 10 raised to minus 6 into 1.1 into 10 raised to minus 5 into 25. Therefore, on calculation, we get the answer as 55 newtons. Therefore, here the correct answer will be option C.